Hi everyone, welcome back to Learn Math with Jessie. Today we're going to cover how to solve systems of equations involving word problems. The first step is to identify and label all unknowns we have in the problem, say for example x and y. The next step is to establish as many equations as unknowns. So if you have x and y, that's two unknowns, so you'd need two equations. For this problem, we have a farmer that has 72 meters of fencing to enclose a rectangular garden with a 1 meter wide walkway surrounding it. If the length of the garden is twice the width, what are the dimensions of the garden? So here I've drawn the garden in green, and now I'm identifying the two unknowns. X is the length of the garden in meters, and Y is the width of the garden in meters. Next, what I'm going to do is I'm going to draw the fencing that encloses it. So we're told that between this garden and the fencing, there's a 1 meter wide walkway. So the distance between the garden and the fence on all sides is 1 meter. This will be useful for establishing the equations. We're told in that last sentence that the length of the garden is twice the width. We therefore can establish the equation x is equal to 2y. The other key point of information is that 72 meters of fencing. We can calculate the fencing because we know that x is the length of the garden, y is the width of the garden, and we know the distance between the garden and the fencing, so it's 1 meter. So then we get that x plus 1, so x plus 2 is one side of that fence. We have two of them, so it's 2 times x plus 2 times y plus 2, and that's equal to the fencing. Now, I covered how to solve for substitution in a previous video, so I will link it here. But essentially, because we have x is equal to 2y, that's our simple equation, so we're going to plug it into that second equation. So anywhere where you see x, you're going to replace by 2y. And then I'm simply solving this using basic algebra knowledge. And then we obtain 64 is equal to 6y, so y is equal to 64 over 6, which we can then simplify to 32 over 3. I'm just missing the meters here because it's important to label the units for all of your variables. So they ask for that dimension, so we also need to find the x value. So here it's 64 over 3, also meters. Moving on to the next problem, we have a rectangle that has an area that is numerically twice its perimeter. If the length is twice the width, what are the dimensions? Again, the dimensions are the unknowns, right? So we have L, which is the length of the rectangle, and W, which is the width of the rectangle. We don't have the units in the problem, so we can leave it like this. So now we establish our equations. We need two equations because we have two unknowns. The length is twice the width, meaning we get L is equal to 2W. Second, we're talking about area and perimeter, so let's remind ourselves of the formulas. So the area of a rectangle is length times width, and the perimeter of a rectangle is 2 times length plus 2 times width. And we're told that the area is numerically twice its perimeter, so the area of the rectangle is 2 times the perimeter of the rectangle. And given that we have the formulas for both, we plug them in. Next, what we have to do is we have to use substitution, right, to solve this problem. So we have length is equal to 2 times width, so let's plug it into our more complicated equation here. And basically, wherever we have length, we replace it by 2 times w. So then we do this, we get 2w squared is equal to 8w plus 4w. We bring the 8 plus 4w to the other side, and it's negative 12w. We factor out 2w. This is a lot of w's. We have one answer that's w is equal to 0, and the other one, w minus 6 is equal to 0. We can't have a measurement that's 0, so we have w is equal to 6. And then we plug this into the other equation, and we get that the length is 12. Here we're deviating a bit from the dimension style problem, but it's the same concept. Here we have a wireless store owner that takes pre-sale orders for a new smartphone and tablet. He gets 380 pre-orders for the tablet and 390 orders for the smartphone. The combined sale of the pre-orders is $388,300. If the price of a smartphone and a tablet together is $1,005, find the cost of a smartphone and the cost of one tablet. So again, we identify our variables. We have X, that is the cost of a smartphone, and Y, that is the cost of a tablet. So we have a lot of different information here. Let's start with the more complicated of the two. We get 300 pre-orders for the tablet, so 300 times Y is going to be the amount made from the tablets in total for the pre-orders, and 390 times X is going to be the amount made for the smartphones. And we're told that this amount made, so the combined sale, is $388,300. So that's our first equation. And our second one is rather simple in comparison. We have that the price of a smartphone and a tablet together is $1,005. So when we write that out, again, we have to use substitution to solve. How do we do this? We isolate a variable in the simpler equation. We plug it into the more complicated one. And we get 380 times 1,005 minus x plus 390x is equal to 388,300. Now we distribute, right? And then we solve like we normally do. So we bring everything that is our variable on one side, everything that isn't on the other side, and we get 10x is equal to $6,400, or x is equal to $640 for a smartphone. Now we use the simpler of the two equations to get that same value or get that price for the tablet. So it's going to be 1,005 minus 640, which is $365. For this next problem, we have Wendy, a loan officer at a bank that has $1 million to lend and is required to obtain an average return of 18% per year. If she can lend at the rate of 19% or at the rate of 15%, how much can she lend at the 15% rate and still meet her requirement? So here again, we first need to identify the unknowns. The unknowns are going to be the amounts lent at 15% and 19% respectively. So here I'm identifying X as the amount lent at 15% in dollars, and Y is the amount lent at 19%. So using the information we have, we know that Wendy is trying to lend out $1 million, right? So this $1 million is going to be comprised of X, so the amount that she lent out at 15%, and Y, the amount lent at 19%. So we have that $1 million is equal to X plus Y. So that's the simpler of the two equations, right? And now we know that some of this $1 million was lent at 19% and some of it was at 15%. That's exactly what we're trying to find out. But we know that she needs to obtain an average return of 18% per year. So a return of 18% per year would be 18% of this 1 million. So 0.18 times $1 million. So that's the expected return. And again, the expected return is made up of 15% of X, right? So the amount lent at 15% plus 19% of Y. So 0.19 times Y. So now we use substitution to solve. So we isolate in the simplest equation for one of the variables. We plug that in to the more complicated equation. 18% of $1 million is 180,000. And then we're just plugging in that 1 million minus X. And then we solve like usual. So we distribute this, or we multiply the 0.19 times $1 million and times the negative X. And then in the end, we get that X is $250,000. Meaning to find Y, we just replace X in the initial equation. And we get that Y is equal to $1 million minus $250,000, which is $750,000. Thank you so much for tuning into this video and for learning how to solve word problems involving systems of equations. See you in the next one.